Alright, so keep in mind that the instructions today are telling us to solve a system by substitution. Now, before we can solve systems of equations by substitution, we need to know what a system is, and we need to know what to do in order to solve it, okay? So let's start with the basics. What does it mean to mathematically have a system? It sounds like something like from outer space, Star Trek, but it's not that complicated. Literally, when you have a system, you have two equations with the exact same variables. So notice here that I gave you two equations, both of them have x and y. That is literally what a system is. Now, in order to solve a system, you need to come up with an x and a y that make both equations true. What I mean by that is that, okay, you need to come up with a magical number x. So when you plug it into this x, you get this y for the y. And when you plug in the same exact x for the other equation, you get the exact same y for the other equation. So that's literally what a system is. That's literally how you solve a system, okay? Now, there are several strategies on how to solve systems. There's graphing, there's substitution. We're going to cover elimination next week, but for the most part, today all we're doing is substitution, okay? All right, so what does it mean to substitute? Someone help me out here. What does it mean to substitute? Don't think about math, just think in general. What does that word mean?
Substitute teacher.
Substitute teacher. What happens to your old teacher?
Disappears.
They disappear. And who does he get replaced with?
Another teacher.
Another teacher, exactly. What I'm trying to get at there is that when you're doing substitution, you're interchanging something for something else. In the reference of your teacher, you have the real teacher, he's sick, he's gone, you replace him with someone else. Okay. So, how do I know what I can replace with what? Well, look at your two equations. Is one of them y equals? Yeah, they both are. Just choose one. Choose the one that's easier to deal with. Which one of these equations looks easier to deal with? The first one. This first equation literally reads y is equal to a negative 3. That means everywhere you have a y, you can substitute it for a negative 3. What I mean by that is that you can substitute negative 3 everywhere you have a y in your other equation. So when a student is struggling on how to substitute what, I usually make them circle the y, circle the what it's equal to, and then circle the y on the other side, because you can kind of visually see, okay, everywhere I have a y, I can change it for a negative 3. Well, where's my y in the other equation? It's right there, so you kind of can see what you're substituting a little bit, okay? So let's go ahead and do the substitution. Now, what do I do? How do I do that? I take my second equation, and I rewrite it, but instead of rewriting a y, I'm going to substitute it for what I said I could substitute, which is a negative 3. So y, which is now a negative 3, is going to be equal to a negative 3x minus 24. Okay? If you could do that, that's probably 50% of the problem. The other 50% is just solving the equation that's remaining. You can ignore everything on top. All you have to do is solve for this equation. Is there any parentheses? No. Do you have variables on one side or two sides?
One.
One. That means that you could solve for it directly, aka get rid of everything else around it. Now, what am I going to get rid of? The negative 3x or the 24?
24.
Let's go ahead and add 24 to both sides. These cancel out. Negative 3 plus 24 is a positive 21, and that's equal to a negative 3x. How do you solve for that negative 3, or for that x? Divide by negative 3. These cancel out. Notice you're left with an x is by itself is equal to a negative 7. So negative 7 is equal to x. Remember, you need to find an x and a y. You have now found your x, which is a negative 7. Now look at your two equations. Which one looks easier to deal with? The first one. Now what is that stating? That y is equal to what?
Negative 3.
Negative 3. So you already have your y. This is what I like to call like a level 1, because most of the work is already done for you, okay? So that is how you solve, and that's the basic concept. So what I want you to do is attempt to do number 2, okay? So see if you can do substitution. I'll be walking around seeing if I could clarify number 1, or if I could help you work through number 2 as well. All right, so again, when you guys are solving systems by substitution, you need to find a substitution equation. How do we know what a substitution equation is? Well, you're going to have y equals, or y is going to be by itself. Notice in this situation, we have two equations that have y equals. Just choose one. I always choose the first one just because it's the first one that showed up. I can see that y is equal to a negative 5x minus 6. That means everywhere I have a y in my other equation, I can substitute it for negative 5x minus 6. Now looking at my second equation, I notice that I have a y there. So this time, I'm going to rewrite my second equation, but I'm going to substitute the y for negative 5x minus 6. So here is that y. I'm going to substitute it for negative 5x minus 6, and it's going to be equal to 3x plus 2. Again, 50% of the problem is the setup. Now you just have to solve for it. Are there any parentheses? No. Is there x's on one side or two sides? 2. So let's move the smaller x over. What's smaller, negative 5 or 3? Negative 5, remember, negative 5 is smaller because it's negative, so what I'm going to do is add 5 to one side and then add it to the other side. Now, these are going to cancel out. Notice you're going to be left with the negative 6 is equal to 3 plus 5, which is 8. Don't forget your x, plus 2. Now your x is by itself. All you have to do is solve for it, a.k.a. get rid of everything else around it. Mind to get rid of the 2 or the 8? 2, so minus 2 on both sides. You end up with the negative 8 is equal to 8x. Dividing by 8 on both sides, you finally end up with a negative 1 is equal to x. Cool? Okay, now, you have found the x. You have to find the y now. Now, which one of these looks easier to deal with? The first or second equation? The second, because you can notice here that y is equal to 3x plus 2. You already know what x is. X is a negative 1, so plug it in for your x to solve for the y. Y is going to be equal to 3 times whatever x is, and x is a negative 1 plus 2. Now keep in mind you can show multiplication multiple ways. I always like to show it with parentheses because it helps me see what I can substitute in. And you'll see how that helps us on 3 and 4. So now let's just solve for this. Y is equal to all this garbage. Let's start with the garbage. 3 times a negative 1 is a negative 3 plus 2. Negative 3 plus 2 is negative 1. So notice now we have our solutions, and coincidentally, our x's and our y are both negative 1s. Okay? All right, let's go up the difficulty. It is not really that much difficulty. It's just, how would I say, a little more pre-work. So let's try 3 and 4. Let's just start with number 3 to see if we have the right idea, and then we'll go from there. So when you look at number 3, right, notice that you have 2 equations with exact same variables, aka you have a system. Now, are any of these equations substitution equations already? Does any one of these 2 have y equals? Yeah, the first one. Notice that this is the first one that showed up. This is the second one. If you look at the first one, y is equal to x plus 10. That means everywhere you have a y in your second equation, you can substitute it for x plus 10. So this is the way you want to go by it. Okay, so this is my substitution equation. This is my equation I'm trying to get the substitution in. So this becomes 2x plus 2 times whatever y is. Now, I like to show times when I'm doing substitution with parentheses because it helps me see that 1 is multiplying. 2, I can just substitute whatever I need to substitute inside the parentheses. And what does y equal in this situation again? X plus 10. Now notice that this is still all equal to a negative 4, so here is my equals negative 4. And now all I got to do is solve for this equation. So let's ask ourselves, okay, what's my first step? Is there any parentheses? Yeah, so let's get rid of those parentheses by distributing the coefficient. Notice that this 2x is just watching. 2 times this x is going to be a positive 2x, and 2 times 10 is a positive 20, which is all equal to a negative 4. Now, I have multiple x's, but are they on one side or opposite sides? Same side or opposite sides? Same. So that means that you can combine these exactly the way they are. That's a 2x and a 2x, which combine 2a. Don't forget your positive 20, which is still equal to a negative 4. Now that your x is on one side and one side only, you can solve for it, aka get rid of everything else around it. So are you going to get rid of the 4 or the 20? 20, so here I go, minusing 20 on both sides. 4x is equal to a negative 24. Let me make sure to write my negative so that it's not too confusing. And now all you have to do is divide by 4 on both sides, and you finally end up with your solution, which is negative 6. Keep in mind that this is technically half your solution, right? You still have to find your y. Now, which equation looks easier to deal with? 1 or 2? I would agree with that. I would say 1. because 1 is just y is equal to x plus 10. Now you know what x is already because you just found it. It equals a negative 6. So you end up with negative 6 plus 10, which equals a positive 4. So what is our solution? Negative 6 and 4, and that is it. You have now solved the system by finding a specific x and y that make both equations true. So one more example, and we'll call it a day, okay? So try number 4, and that'll be it. All right, guys, so for this last one, keep in mind, again, you're solving systems. So you're going to have 2 equations. Now, if you're lucky, you're going to have one equation that's y equals, aka y is by itself. So if I'm looking at these 2 equations, which one has y by itself on one side? Number 2, because notice that y is equal to 2x minus 9. That means that your other equation is your equation that's getting substituted into. So everywhere you have a y, I'm going to change it to 2x minus 9. Now, keep in mind that I kind of visually set myself up. All I got to do is now actually do the substitution. So I end up with the negative 2x plus 4 times y. I like to show times with parentheses, and then I'm going to just place in the parentheses whatever I'm substituting. What am I substituting in for the y here? Keep in mind that that is all still equal to a negative 18, so there's my equals a negative 18. And now I can ignore my system and just solve whatever I have. So notice I do have parentheses, so I'm going to get rid of those first. You end up with a negative 2x plus 8x minus 36 is equal to a negative 18. Okay? Now, notice that you have 2 x's, but they're on the same side. So how do I combine those? Just by adding exactly what you have. Negative 2x plus 8 is a positive 6x. Now your x is combined by itself on one side. Get rid of everything else around it. So let's get rid of that 36 first by adding 36 to both sides. These cancel out. You're going to be left with 6x is equal to a positive 18. Dividing by 6 on both sides, you finally end up with a positive 3. Does everybody agree with that one? Okay. Now, again, you still have to find the y. Which one looks easier to deal with, the first or second equation? Second, which is y is equal to 2x minus 9. Again, you know what x is. X is a positive 3, so let's go ahead and substitute. Y equals 2 times 3 minus 9. 2 times 3 is a positive 6. Then finally, minus 9 is a negative 3. That's it. Now, keep in mind, you are going to be asked to put this in an ordered pair. So remember, when you have an ordered pair, x gets listed first, followed by your y. Your x is a positive 3. Your y is a negative 3. Does everybody agree with that?